at the Hilton?
Yes.
Tell them I say hello.
Okay.
Guys, you're going to have to be comfortable with problems that look like this, problems that have complex fractions in them, evaluating limits. So the process needs to be going through simplifying the complex fraction. You need to be comfortable with doing that. You're also going to need to be comfortable with doing problems like this one down here. With square root signs in them and rationalizing in order to solve. Do you remember the first thing that you do whenever you're working with a limit? What's the first thing that you do? What's the first? What is it?
You try to substitute.
Yeah, direct substitution. Right. The first thing we're going to do is direct substitution. And so when I do that, there's going to be one of three things that I'm going to get out of my direct substitution. I am going to either get out, one, I'm going to get out a number. And if I do direct substitution and I get out a number, then that number is my limit.
You mean a number that's not 0, right?
No, any number, even if it's 0. Any number. If I get out a number, then that's my limit. Or I might get out a non-zero number over 0. Something that isn't 0 over 0. And if I get that, no,
It does not exist.
and the limit does not exist. Yeah. In other words, it's just the opposite of the whole. It's an asymptote. If we're thinking about graphically what it means, it's an asymptote. Right? Or I could get out a 0 over 0. In which that is, Mustafa, 0 over 0 is what?
And there's no limit. Limit doesn't exist.
That's a whole.
Wait, 0 over 0.
Yes.
But we just established that 0 over 0.
No. Non-zero over 0
Okay.
is no limit.
There's no limit.
It's an asymptote.
And then 0 over 0 is a whole.
0 over 0 is a whole, correct. So you're going to get one of these three things. If you get this one, that's the nicest one because you're done. Well, either of the first two, you're done.
But there are other techniques.
Well,
if you try to do direct substitution.
so Mustafa, if you get this one, you're done.
Yeah.
And if you get this one, you're done. If you get this one, you're not done.
Yes.
So you need other techniques. Direct substitution isn't
Enough.
as sufficient. Yeah. So, for example, when I look at this first one and I'm going to do direct substitution and I'm going to put a 0 in for x and I get negative 1 over 8 plus
1 over 8.
1 over 8, which is 0 over 0.
That's
So
determinate.
that's indeterminate, exactly. So what I'm going to need to be able to do is I'm going to need to be able to be comfortable with this kind of thing that I can work towards solving. Why don't you take a minute or 2 or 3 and see if you can simplify this, and then also see if you can rationalize this to work with, to get a limit. are we feeling about this stuff? Max, how do you feel?
I don't see this.
Have a little trouble with it? You see that it's a complex fraction, right? You see that I have this fraction, and in the numerator of my fraction, I have fractions, right? That makes this a complex fraction. Can you just look at the numerator, just the numerator, and combine these two fractions into one fraction? Are you able to do that? Get a common denominator? Do you know how to work with fractions?
Yeah, but like, no.
I don't know how to work with this fraction, these fractions.
No.
Anybody help them out? Hamid? How about this first one?
I started out like getting the common denominator and the numerator.
Yeah. And so the common denominator, I'm going to need to multiply x minus 8 and x minus 8 on this side, and 8 and 8 on this side, right? Does that sound about right? And then I'm going to just combine a couple steps, right? I see my common denominator and I can see my numerator, so it's going to be something like this. The limit, I don't want to forget to write that, as x is equal to 0, of 8 plus x minus 8 over 8 times x minus 8, all of that over x. Is that what you ended up with?
Yeah.
Everybody follow along with that? Now I have some simplifying I can do. I see that I have an 8 and a minus 8. That goes away. So I have really x over 8 times x minus 8, all over x. No. I'm dividing. So remember, when I divide by x, I can think about that as multiplying by 1 over x. Right? So I can think about this problem as this. The limit as x approaches 0 of x over 8 times x minus 8 times 1 over x. That's the same thing as dividing by x. And now I can reduce the x's. So it becomes the limit as x approaches 0 of 1 over 8 times x minus 8.
Mr. Cole, do we always have to write the limit x?
Yeah. Until you do your direct substitution. Because then you are no longer taking the limit, you are actually evaluating. Yeah. But until then, the limit, the expression, this expression, and the limit of this expression as it goes towards 0, they're two different things. Right? I can't just, the expression is not the limit of something, the expression is an expression. So I need to continue to write the limit, in part, mostly to remind myself what it is I'm really trying to do here, right? So now I can do the direct substitution, and I put in a 0 for x.
Can I just put the limit x is going towards 0 at the end of the column?
I prefer you not, because you're going to forget. And that will not suit you well.
So then we can,
Negative 1 over 64. Now guys, I want to stress to you what we are saying here. I want you to be very clear with what you're saying. This, because it's a little hard to get your head wrapped around. If I was to say y equals this, forget about the limit, just y equals this. And I'm graphing this function, y equals this. And I ask you, when x is 0, what is y? And you look at this and you plug in the 0 and say, well, when x is 0, y is undefined. If I look at the graph of this function, the graph does not exist when x is equal to 0. I cannot evaluate it when x is equal to 0. However, I can get as close to 0 as I want. And as long as I'm not 0, but I'm very close to 0, I will have outputs, right? And my outputs, as I'm getting closer and closer and closer to zero, as I get closer and closer, my outputs are getting closer and closer and closer to negative 1 over 64. That's what we're saying. We are not saying that when my input is 0, my output is negative 1 over 64. We're saying that as I get close, my outputs are getting close. And I can get as close as I want. I can get infinitely close to 0, and my outputs will get infinitely close to negative 1 over 64. Okay? Try this one. Remember what you're going to have to do. Remember, we're not asking what happens when B is 3. We're asking what's happening when B is getting closer and closer and closer to 3.
What would an application of a limit problem be? Like,
You're about to see one, buddy. I mean, not like here in this lesson.
it seems like it could be useful, but I still don't know what.
It's not,
This one? Well, what do you get when you
well, we
do?
substitute for -3 for B values and the number could be something over 0.
Well, what's the something?
-3 plus 3.
That's the over 0 part, but what's the something?
Oh, yeah, that's one. -3 plus, oh, wait. I thought it was plus. It's indeterminate.
It is indeterminate. That is correct. You'll find that most of the problems I give you are going to end up being indeterminate. What do you do with this when you find it indeterminate? What with this kind of indeterminate? What rationalize it. Yeah. Go ahead. You're going to multiply the top and the bottom by the square root of b plus 7 plus 2. Right? You're going to multiply by the conjugate.
Is that the conjugate or the complex conjugate? Or the same thing?
This country was I.
Yeah, the complex conjugate would be
Imagine what do you want us to do?
multiply. Here, let me get you started here. You're going to multiply the top and the bottom by the square root of b plus 7 plus 2 over the square root of b plus 7 plus 2. Multiply the top and the bottom by that. Let's just talk our way through. Let's work our way through together. I want you to notice, Fahim, the reason I'm multiplying by the conjugate is because now I'm multiplying this a minus b times a plus b, right?
Is it because you got 0 over 0?
Yeah, well, that's exactly right. That's the only time I ever have to do more work. If I get a number, I'm done. If I get something over 0, some non-zero over 0, I'm done. But I got 0 over 0. So I get this a minus b times a plus b. So my numerator, I'm going to write it, highlighting what's really happening with it. -3 is going to be b plus 7 minus 4. And you see, I'm writing it that way just to highlight that I've done that. This is a squared, and this is b squared, right? It's a squared minus b squared.
I immediately simplified it.
Okay, you can, but let's just finish our thought off here. This becomes b plus 3 times the square root of b plus 7 plus 2, right? And as Mustafa says, I can see that the numerator simplifies. B plus 7 minus 4 is b plus 3, right? This whole thing right here is b plus 3. And I have a b plus 3 in the denominator, so this can cancel and reduce. This can reduce with this. And I'm left with
1 over the square root of b plus 7.
yeah, I'm evaluating the limit as b approaches 3, negative 3, of 1 over square root of b
plus 7 plus 2. Wait, what did you do? With the b plus 7 and the minus 4 and
Well, that simplifies to b plus 3. Right, b plus 7 minus 4, b plus 3. And I have a b plus 3 in the denominator. All right, now I can do direct substitution, right? Put in a -3. I'm going to get 1 over 4.
Ultimately, you always direct substitution.
That's it, correct. Ultimately, I will get my answer by direct substitution.
So at that point, we're not saying the limit has to be equal to -3. We know.
Exactly. That's exactly right. Once you do the direct substitution, then you are not taking the limit anymore. That is your answer. That is the limit. So, if you want to make sure you're okay with these, we're going to come back and take a look at these in an application here in a little bit. But I also want to go over with you one other type of problem that I want to. Do you remember the 3 situations that arise in which a limit does not exist? 3 situations. Let's think about 3 situations graphically, in terms of graphing.
I'm sorry to interrupt, sir, but we have the second type of, there's number, you just get a number and then there is a limit. And if you get 0 over 0, then it's indeterminate. But if you get a number over 0, the limit does not exist. What if you get 0 over a number?
That's 0. 0 over 6 is 0.
Yeah, and that would be a limit.
Yeah, that's a number. 0 over 6 is a number, yeah.
Not a limit.
I mean?
When limit increases or decreases on bound.
Okay, that's one type that my limit doesn't exist. If I'm thinking about the graph of my function, and as I approach a number, my graph increases without bound. Or, as I approach the number, my graph decreases without bound. Meaning it gets bigger and bigger and bigger and bigger and bigger. The closer I get to this number, the bigger it gets. What do we call that situation? That's an asymptote. When I have a vertical asymptote. If I have a vertical asymptote at x is equal to 2, for example, my graph, as it gets closer to 2, goes up forever.
So at that point, we don't have a limit.
The limit as x approaches 2 does not exist. That's right. Or if it comes close and it goes down forever, that limit does not exist. What's another case where the limit does not exist, Max?
so like the sine cosine graphs where it's like 1 over x or something.
Okay, so that's the third situation. That's the one I'm not terribly interested in you having too much experience with because it doesn't happen all that often. But you're right, it does exist. Where my graph is periodic, it's going back and forth, but as I get closer to a number, the periods are getting shorter and shorter and shorter until they ultimately get indiscriminately small, and I'm just bouncing back and forth between 2 numbers. That one's less important.
So would it be like horizontal lines?
No? No? Sanjeev?
Would be when the limit of a negative number and a positive number aren't equal.
Okay, the limit as I approach a number from the negative side, and as I approach that same number from the positive side, are not the same number. Right? When I approach 2 different numbers, I'm approaching 6 from the positive side, and I'm approaching 3 from the negative side, then I would say my limit does not exist. And let me show you an example of what we're thinking about with this. These are fairly common functions, types of functions, and you know what kind of function this is. What do we call it? Piecewise, right? Whenever we're dealing with piecewise functions,
You have to evaluate yourself.
We're often interested in that point where I change from my one function to my other function. In this case, where x is equal to 1. Right? What's happening at that place where x is equal to 1? I am coming from using this as my function. On the left-hand side, I'm using 2x plus 1 as my function. The minute I hit 1, start on to the other side, I'm going to use 4 minus x squared as my function. Right? So I want to know, I'm very often interested, when I get to 1, is my ending place from the 1 the same as my starting place for the other? In other words, am I approaching the same limit from the left as I am from the right? Or am I approaching two different limits? I need to ask myself, excuse me, I need to ask myself, what is the limit of my function as I approach 1 from the negative side? When I look at this function, I can see that, I'm trying to draw this here. Here's 1. Suppose this is x is equal to 1. When I'm over here, the function I'm using to define me is 2x plus 1. And when I'm over here, the function I'm using to define me is 4 minus x squared. So I need to ask myself, what's happening? What number am I getting close to as x is getting close to 1 from this side? What number am I getting close to as x is getting close to 1 from this side? So from each side, I'm using two different functions. I'm not asking what happens when I am equal to 1. I'm asking what happens when I'm getting closer and closer and closer to 1. So, just like my regular strategy, the first thing I want to do is try direct substitution. It's a normal strategy. The difference is, between this and the other types of problems we've seen, the difference is that my direct substitution is going to be into one function here, and it's going to be in a different function here. I'm going to be directly substituting into 2x plus 1 here. And I'm going to be directly substituting into 4 minus x squared here. So when I do my direct substitution into 2x plus 1, when I ask myself, what is the limit as x is approaching 1 from the negative side? Don't get confused, it's not approaching negative 1. It's approaching 1 from the negative side. What is my direct substitution into my function for the yeah, I put a 1 into 2x plus 1, and I get out a 3. Yeah.
It says that x is less than 1. So
Yeah.
how do I substitute 1 in?
Excuse me?
It says, well, so the function is 2x plus 1, and you asked us to evaluate for the values when x is less than 1.
Yes.
So how do we just substitute 1 in?
Because remember, the limit is saying, we're not asking what happens when x is equal to 1. I don't care what happens when x is equal to 1. And in fact, for my function, x isn't defined. The function isn't defined when x is equal to 1. I'm only asking when x is getting closer and closer and closer to 1. That's okay here. Right? I don't care what. Equal to 1 doesn't matter. As long as I'm less than 1, I can be as close to 1 as I want. And I'm using on the negative side, and I'm using this top function. Right? 0.9, guess what? I'm up here.
Yeah.
0.99, I'm still up here. 0.999, I'm still up here. I can get as close as I want. So the limit can still be applied here. It doesn't have to be defined at 1.
But you still can't substitute 1 in.
I can to evaluate the
To
limit.
evaluate the limit, not to evaluate the function.
That's right. That's right. That's exactly right. Yeah. So when I'm coming from the right-hand side, I'm using the bottom one, right? And so I'm going to do direct substitution into the bottom one. And what do I get when I do direct substitution into the bottom one? Yeah, I also get 3. Yeah.
You know how after the one you put those negative and positive?
Yeah.
Show? Is that like a universal math?
Yes. Yeah. That, you'll see that in any technical case. So, if these two numbers are the same, then that's my limit. If these two numbers are not the same, then what? My limit does not exist. So in this case, my limit is equal to
So we both have the same.
3. Because they're the same number.
What if they were both 0? Or I mean, yeah, both 0.
Then my limit would be 0.
And if you had a fraction and both fractions were indeterminate in the
If I had 0 over 0 and 0 over 0, then I would have to apply the rule to this one and until I can do direct substitution, and apply the rule to this one, and then see what they're the same. What's that?
Would you give it something like that?
Probably not. No. For the piecewise, it'll just be direct substitution, and it usually is.
We don't get it.
I mean, you can, but it's going a little further than you need to. Now, guys, I want to talk a little bit about. Various graphs. One of the things I want you to be able to do is I want you to be able to look at a function and determine what the limit is as x approaches something or another, whatever x is approaching. But I also want you to be able to look at a graph. And when I see this graph and I ask what is the limit as x approaches whatever, I want you to be able to answer for me. I'm going to give you several example graphs. There's nothing, I don't have any function in mind. Supposing you were looking at this graph and I could ask you basically 4 questions. What is happening when x approaches some number? I've chosen the number 1. Could be anything here. What happens when x approaches 1 from the negative side? What happens when x approaches 1 from the positive side? What happens when x approaches 1? And what is f of 1? Those are basically the 4 related questions that I can ask you about this. So let me give you a couple of graphs, several different versions of this, and see if we can answer the question. Here's one. Try this one. Supposing you saw that, and what the graph looks like isn't important. In fact, the details are right in here. When I ask you the question, what is the limit as x approaches 1 from the negative side? What would your answer be? 3. Yeah, the answer is 3, right? Because I have this hole at 3, 1 comma 3, and the closer from the left side, the closer my x value gets to 1, I'm getting closer and closer and closer to that hole where the y value is 3. So this would be 3. And what would the limit as x approaches 1 from the positive side be?
negative 1.
What is it?
Negative 1.
Negative 1. Perfect.
We can't determine the way because they're not the same.
Okay, so what is this? This does not exist. I don't even need to see this. As soon as I see this, I know that this does not exist. Right? DNE stands for does not exist. And what is f of 1?
It's either 3 or
Undefined.
oh no, it's undefined.
It's undefined, good. Because I have an open hole at both spots.
What if one just had a was okay.
What?
What if it was just and we like pass the value as one.
Is that possible?
One whole?
Yeah.
What's the other one?
No.
So,
Close whole.
okay, so I'm gonna do that. What if I said this? You know your answers here. What if I change this to this?
Is there a function that could actually have that?
Yeah.
That includes it, doesn't it? It includes it.
That's weird.
Okay, now, I've changed the graph. How does that change my answers? What changes on my answers?
From the positive side?
Yeah.
One from the positive side?
One from the positive side should become what now?
Uh,
What's it gonna change to?
oh wait.
No, it wouldn't be does not exist.
One from the positive side does not exist?
X is approaching, as X is approaching.
Because that's inclusive, so.
So hold on here, okay, I'm getting confused as to what we're answering. What changes? Does this change?
No, it does not change.
Okay, does this change?
No.
Yeah.
But you,
Are you sure?
well,
It's not negative one anymore, because it's not a limit, it is including that now.
But it does approach that point as x approaches 1.
Okay,
Positive side.
what am I concerned with limits? Am I concerned with what happens there? Or am I concerned with what happens as I'm getting close to there?
when the approach has to change.
As you're getting close to this.
Yes, I don't care what happens there. Whether that hole's filled in or not, does not matter. Doesn't matter at all to me. The fact is I am getting close to -1. Doesn't change. Okay, how about this one?
Doesn't change.
Does not.
Does not exist still. How about this one?
That changes, right?
Okay, good. That changes. That's going to change from undefined to
-1.
-1, exactly.
Now, what if both of them were?
Okay, what if I did this?
So then, what would your F1 be?
Plus 3 or
What, -1 or 3?
No, I throw this problem out. If someone asked me this on a test, I would throw the problem out. That's not a function.
Oh, it fails the
Vertical line test. Right?
because it intersects the point twice.
Right, that's not allowed. You can't have that. Be careful.
Asking the limit of the function.
Yeah, it isn't a function. Okay, what if I did this?
That's the only.
Okay, is that a function?
Yes.
Okay, what's the limit as x approaches 1 from the negative side?
Same.
Same? How about here? How about here? Same? How about here?
It's gonna choose 1.
Yep, that's the only change. My limits don't change at all. I'm still approaching the same things.
It's just the evaluating change.
It's just my function value there changes. What if I did this? What if I changed my graph to be this?
This is the.
Well, your limit as x approaches one from the negative side would not change.
Okay,
So this would change, and then you get
this changes to 3.
yeah.
Good? Alright, then the next
Now
one.
you limit the us exists.
3.
And what is the limit?
3.
3, yes, correct.
But FF1 would be undefined.
Good. Perfect. What if I did this?
Then normally after 1
F1 change to the.
And negative.
Okay, this doesn't change, this doesn't change, this doesn't change, this changes to -2. Perfect. Very good. Make sure you're comfortable with seeing a graph and evaluating from the graph what the limit is from the left and the limit from the right and what the function value is there. Okay. Guys, let's talk about 11.3. This is a fairly important one for you to get under your belt. I want to start by saying to you that I have a series of drawings here, and each drawing is meant to be kind of the previous one with something else added on to it, right? So you see in the first one, what I want to look at is, I see that I have this blue graph, and this blue graph is some function f of x, and it kind of looks like it's a parabola. I don't want you to assume that it's a parabola. It looks kind of like it's a parabola, but maybe it does some other things outside of the window that we're looking at. It's just a curve, right? That's all. That's all I care about. It's a function that's a curve. Now, I want you to remember, think back to earlier in the year, and you may or may not remember, hopefully you do, that there's several times that we've been making graphs. And when we're making our graphs, I encourage you, strongly encourage you, to make your graph a smooth curve. Remember me saying that at various points in time, that I don't want you to make your graph come to points. And sometimes it's a little hard to do because maybe, you know, it's just going back and forth in a very narrow space, but it is a curve all the time. And the reason I'm asking you to do that is because there are things we can do